warahmatullahi wabarakatuh. My name is Nurina Hanani binti Zainal Anwar.
Hello, Assalamualaikum. My name is Aisha Nabila binti Rosli.
And Assalamualaikum. My name is Muhammad Fidel Hakim bin Fatah Yasin. We are from TTS1. Okay, tonight we are going to be explaining about question number 4 in the tutorial chapter 2 of Physics 2, TMS0334. That's it for
The
this.
question that given to us is what is meant by coherent source. Coherent sources are sources that have the same frequency and maintain a constant phase with respect to each other. On the side note, that there are two types of coherent source, that is in-phase and anti-phase coherent source. For the in-phase coherent source are sources that have the same frequency and zero phase difference, while anti-phase coherent source are sources that have the same frequency and phase difference of pi, that is 180 degree. Thank you.
The question 4b, red light of wavelength 644 nanometer from a point source passes through two parallel and narrow slits 1.0 millimeter apart. The distance between the two slits and the screen is 1.0 meter. Determine the distance between the central maximum and the third order minimum. Based on the question, we know that red light passes through two parallel and narrow slit 1.0 mm apart. That's mean the distance is here, 1.0 mm apart. Next, the distance between the two slits and the screen is 1.0 meter. So the screen is here and the slit is here. The distance between these two is 1.0 meter. And the question asks, determine the distance between the central maximum and the third order minimum. That's mean this one is a central maximum and this one is the third minimum. So we need to find the distance between this. So given lambda is equal to 644 nanometer.
Okay. The question asks us to find the distance between the central bright fringe and the third order dark fringe. As we refer back to the page 34 of textbook, we will know that the equation of finding the distance between the central bright fringe and the third dark fringe is yn equal to n plus half lambda capital letter D over V. Okay, as we get the equation, we have to substitute the value. How do we know the value of m? First one, we understand that the central fringe is a bright fringe. So the central order number of the central fringe is 0. And what follows after it is a first order dark fringe. Also have the order number of 0. And for the second dark fringe, the order number is 1, and the third dark fringe order number is 2. Since we have obtained the value of 2, we substitute it into the equation. M is 2, okay, plus half, close the bracket. And what is this lambda over here stand for? It is the wavelength of the red light. The wavelength given was 644 nanometer. So we have to convert it into meter. We convert it into 644 times 10 to the power of negative 9. And next one is capital letter D. Capital letter D stands for the distance between the slit like source and the screen, which is 1 meter. Since the unit is meter, we don't have to convert it. So we put 1 over here, over with small letter d. Small letter d stands for the distance between the two light sources, which is 1.0 millimeter. Remember, we have to generalize the unit. So we change 1.0 millimeter into 1.0 times 10 to the power of negative 3. Alright. As we have obtained all the value needed, just put the value in the calculator and you will get the answer of the answer is 1.61 times 10 to the power of negative 3 meter. Why meter? Because we have converted all the values in here into meter. And since it is all of -3, we can kind of write it as 1.61 millimeter. So what is 1.61 millimeter again? It is the distance between the central bright fringe and the third order dark fringe is 1.61 millimeter. That's all from me. Thank you. That's all the explanation from us. Thank you for your attention. Bye.